Welcome to Earth Science, everybody. You should have already done the bead drop lab if you're here. If you haven't, we got to meet up and take care of dropping all those little beads in the tubes to think about settling rates, to think about how quickly deposition happens with different sized particles in still water. And we'll have to come up with some ideas about what might happen if the water's moving, but you're clever folks. You'll figure it out. Your job here, don't get intimidated. You're only going to be plotting a total of 6 points, so don't panic. You'll chuck in your numbers for your 10 trials of small, medium, large. You'll chuck in your averages, and then we'll put all of them together on the board. We'll get class averages. I'll also put those on the survival guide. Then, what you're going to do with your averages is plot your 3 points. So what I'm going to suggest is give yourself a nice big dot like 6. Say my averages will be orange. My class averages will be purple. And you're going to plot. Now, you'll have to do the numbers you have, right? I don't have them. But at 4, whatever that number is. So at 4, let's say it was right about there. These go by 0.2s, by the way. At 8 in size, because the bottom, the x-axis is your size. Let's say it was right about there. And at 12, it was right about there. Now, do those accurately using whatever numbers you have here. I'm just fudging it because I don't have any numbers, but you do. So you'll end up with a line that kind of looks like that, or dots that kind of look like that. This is where we're going to change it up a touch. Rather than doing our usual play connect the dots, I'd like to do a best fit line, a straight line. Make it thinner than your dots. And what you'll do for that is what one perfectly straight line best represents the dots. So the line tool, you can just kind of, it didn't come out purple. Or it did come out purple. I wanted orange. You can do that. Then if you're not happy with it, you can go to the select here and you can grab the ends and you can say, maybe it look a little bit better right about there or so. Now, yes, I missed all of the points, but yes, this line probably best represents about what the trend is given the data. Okay, that's a best fit line. You've probably done it before. You'll do the same thing for purple. Yeah, they might end up pretty close to each other, but you can do it. So 3 dots in a line, 3 dots in a line. It's not too bad. I know there's a lot of numbers here, but don't get scared. Then let's talk about some questions quick and you'll be on your way. Interpolate and extrapolate. So how quickly would a particle of 10 millimeters settle? Which I don't have. If I had a plastic bead that was 10 millimeters in size, how long would it take? And you might say, well, we don't have it. How do I know? Well, you've got a graph that represents the trends for all these different sizes. So use your graph and say, okay, at 10, if I go up to the line and come over, that's how long it takes. Because this is size, this is time. Extrapolate's the same idea, only like outside your data set. What if we had one that was 15? If we had 15, it would take about that long to settle. Not too bad. And you'll do it for both lines, though, your 2 colors, yours and the class average. And again, those answers might be pretty similar. 3 and 4, these look like the same question, and everybody that doesn't watch the video is going to say, Mr. F, these are the same question. They're not. There's a difference. So sit for a minute and think. What's the difference between rate and time? Rate is like speed. So if you and I were to race, only I get to use a car, who's going faster? But then also who's going to take more or less time? And you'll see that those are different ideas. Which beads have a high rate? Which beads take less or more time? How do you want to write it? Remember when you say state the relationship, the first word that comes tumbling out of your mouth should be with a smaller font than this. As this thing changes, how does this thing change? As this thing changes, how does this thing change? If you put the same answer on both of those, one of them is wrong, I promise. Think about how this really would work in nature. Like this is a controlled situation, a tube of water and some beads. What would it really do if we really had different particle sizes, like the ones we looked at the other day? Boulders, cobbles, pebbles, sand, silt, clay. Those are your different particle sizes. How would they behave like in real life in nature? 7, think about what might happen with some of those beads. Why did some data points look a little bit weird? Rate of changes. I'm going to crack heads on it. They're either done 100% right or I'm returning this lab as incomplete with a link to this moment in the video where I said you should have watched the video the first time. Change in value divided by time. When we do these, I want the equations written out, which I've been saying since the beginning of the year, and we're getting better and better, but we still have some progress to make here. So it's a speed. How fast were the beads going is really what it was. What was the change in value? How far did they travel? All of them traveled 50 centimeters. Now, if you'd rather use the text tool here, that's fine. Over however much time it took, some number of seconds. which means your answer is going to be equal to 50 divided by whatever that number was from your lab, some number of centimeters per second. That's your label on rates, on speed. Like your car says miles per hour. That's a distance per time. This is the same thing, a distance per time, centimeters per second. So the top number on all six will be 50. The bottom numbers on all six will be a little bit different, but you just steal them from these numbers right here, and you are good to go. All right, use your noggin then. Which particles settled first? Which particles would settle fastest? And then if you don't remember the names of the particles, open up ESRT page 6 and you'll have the name of all those particles and you'll know which ones are bigger and smaller. Then this thing right back here, grab one of Finn's sediment tubes. It's that plastic tube with the two white things. I suppose I should grab one. I'll show you in class where they are, but you stir these around a little bit, mix them up, and then stop, put it on your desk, see what happens, and do the best drawing you can. You know I'm terrible at it. I'm not going to like get on you about art. Do your best to draw out about what it looks like and explain what you think that shows us about the way that particles settle, because this is, after all, particles settling in water. It's not like too out there of an experiment. You can do it. All right, everybody. Good luck. Keep it up. So long for now.